This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com.
But a way of measuring how fast prices are going up is index numbers. The question 1, those index numbers that are listed are saying in 2001, if something cost 100, then the same thing in 2002 would cost 105, in 2308, and so on. I think you're all clear of the principle. It's just showing how the prices have moved. Just one tiny bit of terminology in case it is mentioned. The start year, or the year you let be 100, we always start with 100, it's called the base year. If there's any mention of the base year, that's the year when you let it be 100. Am I making sense, everybody? So, not relevant here and not relevant really for the numbers, but just in case it was mentioned. 2001 here is our base year. So all those numbers are showing the prices relative to 2001 when it was 100. Okay? Well, there are a million different ways you can use them, but they're all the same principle. So just the one question here is enough. It says, if this product cost $25 in 2002, what will it cost in 2005? Alright? Well, again, don't just learn a rule. It's one of those things, if you see the logic, there's not really much learning. It was $25 in 2002. And of course our index numbers, in 2002 the index was what, 105. In 2005 the index number was 109. And so I hope you all appreciate what the index numbers mean is simply that if it had cost 105 in 2002, for every 105 it would now be 109. And so what would $25 have grown to? In 2005, it would be $109 for every $105 it was in 2002. Now, if I'm not explaining it well enough, shout. But for every 105 you spent in 2002, you'd be spending 109 in 2005. Alright? Now please, I say again, I mean the arithmetic's not hard. If I've not explained it properly, if it's not making sense, ask me. I really, really think this is somewhere that shouldn't be just learning a rule, as I said a moment ago. Well, you all seem happy enough, so what's the answer? 109 divided by 105 times 25. Is it 25.95? Fine. Alright, well, I don't want to waste your time, but because there are bound to be 2 or 3 of that, just basic index numbers, could you all for me, it won't take you 2 seconds I hope, but for the same question, the same index numbers, if it cost, let's say, $45 in 2004, could you just write down to the nearest cent, what did it cost in 2003? Anybody?
42.26.
I think she's right. They're using the index numbers. In 2004, the index is 115. In 2003, it was 108. So make sure, obviously, you went the right way round. But it means for every 115 you spent in 2004, it would have only been 108 in 2003. But it was 45 in 2004. So 108 for every 115. In 2003, it would have cost... Is that what you said, 42.27? 26. Let's not argue over 1 cent, but yes, sorry. 42.26. Did we all get that? Or if we didn't, are we all happy? Okay, well, I actually think, in all likelihood, that's probably all they'll ask on index numbers. However, they could check, you know what we mean by Laspeyres and Paasche. So let me remind you with example 2, which I've kept terribly short. They could certainly make it slightly longer, but any longer wouldn't make it hard. It would just take more time. Because, well, Laspeyres and Paasche relate to the fact that index numbers very often, instead of just looking at one product, they publish index numbers as a sort of average. I think all countries publish a number to show how much the average shopping basket has gone up in price. I think you know what I mean. And so, I've told you there a very tiny shopping basket, that there are only 2 products. In 2010, you bought 100 A's and 200 B's, and the costs were that much. In 2011, well, the costs had gone up to 8 and 13. But in 2011, people were buying different quantities of the 2. 150, 180. All right? Well, a price index, we're going to let 2010 be the base year, so 2010 will equal 100. And so in one sense, it's just working back what we did before. You know, if the cost has gone up to this much, what would 100 have gone up to? I think you know what I'm getting at. The only thing about typical shopping baskets and Laspeyres and Paasche is that if you're measuring the increase in price, it's only sensible if you use the same shopping basket to get the cost in both years. And so, first of all, Laspeyres, we're going to work out the cost of the same shopping basket in both years, but with Laspeyres, you use the base period shopping basket, or the base period quantities. And that's the learning bit. We'll do the arithmetic. I don't think the arithmetic's a problem, but do learn. For our Laspeyres index, we use in both years the quantities in the base period. So check me, let's see how quick we can be. In 2010, A and B, well, the 2010 quantities were 100 and 200. And in 2010, how much did that basket cost us? A was $5. B was $12. $2,900 in total? To get a price index, we need to know how much it would have cost in 2011. But I hope you understood what I said, and make sure with the figures, you work out the cost of the same shopping basket. So despite the fact they were buying different, if they'd kept to 100 A's and 200 B's, how much would we have spent in 2011? A would have been $8 a unit. B would have been 13. 34. Everybody? And finally, the index number itself. Well, that's just the work back, effectively, of what we did before. That here, for every 2,900 you spent then, you would now be spending 3,400. Well, we base it on 100. If it was 100 in 2010, well, again, every 29 is worth 34. And so, in 2011, the 100 would have become, I keep losing my calculator. Who's stolen it? Oh, here it is. It would have become, is it 117, please? I'll put 0.24, but in the exam almost certainly it would say to the nearest unit. Does that make sense? Alright, well, you can do the other one. Just let me remind you what the other one is. Sorry, Laura, you're okay? Yeah. The other way of doing, I mean, the problem, again, I don't have all the chat, it'd be wasting time. The only problem with that is, of course, after a few years, if you're always using the same shopping basket, it starts to get very out of date, you know? And so, the alternative, to be more, if you like, up to date, is Paasche. Exactly the same idea, and you must use the same shopping basket both years. But with Paasche, you use the current year's quantities. Otherwise, exactly the same. Use current year quantities. So I want the index number for 2011. Well, can you take the 2011 quantities, compare the prices, and give me a price index, please? Is that correct?
Why are you not doing the opposite? I mean, if you are taking the base year 2011 and 100 will be 2000.
Oh, no. Sorry. I didn't write. Oh, I have written here, in fact. No, 2010 is the base year.
Okay.
It does say that, and it usually will. I mean, it will be. Yeah, you don't tend to work backwards on index numbers in that sense. So the base year's 2010 still. But instead of using 2010 quantities, yeah, you've got it. But if you're doing an index number for 2011, you'd use 2011 quantities in both years. If you're doing it for 2012, you'd use 2012 quantities, and so on. Yeah, but you'd always be comparing base year prices with current year prices. Alright? So have I made that clear? You're obviously happy, and so the rest of us? Everybody? So that's certainly, I'm actually dubious as to whether they go that far, but they certainly could ask that. And of course they could make the shopping basket a bit bigger. In real life there'd be lots of things. If they do ask it in the exam, I can't believe there'd ever be more than 3, but you know, if you're happy with the idea, that just adds a bit of time. Okay? Now then, I'm going to mention one more thing, otherwise you might think I'm lying. When I give you a test, because I've got to do some other things first, there won't be that many index numbers. One of the questions BPP puts in mentions another index number. There's Laspeyres, there's Paasche. It mentions another one which I don't believe is even in the syllabus. I'm tempted to say, can you cross out this question in the test? But I will mention, it's easy numbers, but I really wouldn't go home and learn this. I just can't believe she can even ask it. But a man called Laspeyres and Paasche, Mr. Laspeyres invented one, Mr. Paasche invented the other, yeah? And Mr. Fisher was a clever bastard. He said, there's problems with both. He invented what he called the ideal index. And you're going to laugh when I tell you what it is. So I say, I wouldn't even learn this, but it's so easy. What he suggested was, I think there's a bit of a cheat. He said, well, you know, there are good things about Laspeyres, there are good things about Paasche. He said, simply take the square root of one times the other. So I'll do it because we've got all the figures and it actually takes 2 seconds now. But we worked out the Laspeyres index number to be what? Was that the answer? Yeah, 117. I won't bother about the decimals. To the nearest number, 117. The Paasche index number to the nearest number was 122. So Fisher's ideal, multiply and take the square root. I get, is this right? Please, 119? Okay. So I said what I need. Well, I'll fall over if that's asked, but regardless.